Hey everyone, I'm Rongji. In this video, I'm going to walk you through how to create DVB-S2X time slicing and beam hopping signals using Keysight Signal Studio. With the latest N7623C Signal Studio 2026, you get full support for DVB-S2X course features, time slicing, super frames, and more. It's fully ETSI compliant and works across Keysight signal generators such as VXG-C, MXG, and PXI transceivers. If you are working on satellite receiver testing, you will love how simple this tool makes things. Quick refresher, DVB stands for Digital Video Broadcasting. We've seen it evolve. DVB-S, then DVB-S2, and now the supercharged DVB-S2X. What's new in S2X? NXM time slicing reduces receiver complexity, process only the necessary stream, not the entire wideband signal. NXE superframe, better sync, channel bonding, and yes, support for beam hopping. You'll find that these features are a perfect fit for things like UHD TV, IP services, and the latest high-throughput satellite networks. Here's what we are covering today. Part 1, how to build a basic DVB-S2X peer frame. Part 2, how to level up with time slicing signals. Part 3, and finally, how to combine super frames and time slicing for beam hopping testing. Let's jump right in. First, let's build a basic DVB-S2X physical layer frame, just called a peer frame. Inside Signal Studio, let's head to the Format menu. Select DVB-S2X. Onto the Carrier Settings page, you've got 4 submenus. In Basic menu, set carrier frequency, phase, and power here. In DVB-S2X Settings menu, tweak roll-off factor, modulation, coding rate, and symbol rate. Here's a tip. Set setting support DVB-S2X to false, and you are in DVB-S2 mode. Modulation maxes out at 32 APSK. Let's switch it back to true. And now you are in DVB-S2X mode, and modulation is up to 256 APSK. Notice that the VR SNR header setting option appears. For each setting, need guidance, just use the hint feature for helpful reminders as you go. You can see that it tells you when VR SNR header setting is true. Insert pilot is always true. Let's enable it, and the Signal Studio automatically enables insert pilot here. We'll leave time slicing and super frame off for now, just focusing on the basic peer frame. Finally, go to Data Source Settings menu, pick your payload data type, binary file, test pattern, or user-defined data. You can even export this user data for reuse. Need more carriers? Just hit the plus or cross button here to add or delete carrier. Now let's take it up a notch. Time slicing with DVB-S2X peer frames. What is time slicing? Think of it like channel serving for your receiver. The modulator sends multiple services over a wideband carrier, typical 200 to 500 MHz. Each peer frame gets a time slice number, TSN. In NXE part, it defines TSN value 254 and 255 are reserved for dummy frames and do not represent actual services like other TSN values. Your receiver decodes the necessary slices, ignores the rest, allowing for more efficient and cost-effective receiver designs. In Signal Studio, let's turn on time slicing structure. Header and payload settings now move to the TSL page. Each TSL page equals 1 peer frame. On the TSL page, you can set the TSN number, modulation, coding rate, and payload for each time slice. Want more slices? Add them with the plus button here. Now we have 3 time slices. Now head back to the carrier page. Define your slicing pattern. For example, index 1, 2, 3 means 3 PR frames with TSN numbers 1, 7, and 8. Reorder or repeat numbers to change the sequence. Next up, the advanced stuff, beam hopping with DVB-S2X superframes. Here's the concept. The satellite has multiple beams. Each beam serves a cluster of cells. During each cycle, the satellite shifts its beam from one cell to another, illuminating each in sequence, a process known as beam hopping. Each dual time uses N7623C superframes. You can stack multiple superframes, each with different size. Each superframe bundles multiple PR frames, and each PR frame can have different lengths. You can even mix time slicing inside beam hopping for maximum flexibility. So here's the logic to create your testing signal. How many dual times do you have? How many superframes per dual time? How many PR frames per superframe? And do you want time slicing? N7623C defines 3 formats. Format 5 for periodic beam hopping, Format 6 and 7 for traffic-driven cases. Each superframe has a header, payload, pilots, and 2 postable fields. One for the end-of-dual illumination and one for beam switching. The basic building block is a capacitor unit called CU, 90 symbols each. You can define how many CUs make up each superframe. Let's build a real-world example in Signal Studio. 2 dual times for 2 cells. Cell 1, 1 superframe with 496 CUs. Cell 2, 2 superframes, one with 736 CUs, one with 464 CUs. Inside, Cell 1's superframe has 2 PR frames. Cell 2 superframes has 3 PR frames and 2 PR frames. Here's how to do it. 1. Let's turn on superframe structure. Step 2. On the superframe settings menu, pick your superframe format based on N7623C. Step 3. Define the number of superframes and the cell ID sequence here. Example, 1, 2, 2 means 3 superframes, and the last 2 belong to cell 2. Next, configure each superframe. Step 1. Set postable switching length. For example, second element 0 here indicates no beam switching. Step 2. Assign CU counts, which sets superframe size. Step 3. Set scrambling indexes based on your cell IDs. Step 4. You can assign the same protection level to all superframes, or you can specify different levels for each using an array. Then configure PR frames. Set the number of PR frames for each superframe here. Then, on the PR frame list, the PRS list array size matches the total PR frames. For example, 2 plus 2 plus 2 equals 6. Let's turn it back. You can set modulation and coding rates by PRS code value. For example, change PRS code to 140 means 8 APSK. Let's turn it back. On time slicing 2, you can create a TSN array for all PR frames, and you are mixing time slicing with beam hopping. And that's it. In just a few steps, you created basic PR frames, time slice signals, and even beam hopping scenarios, all inside Signal Studio. Want to try it yourself? Grab a free trial of N7623C Signal Studio 2026 on our website.